Welcome to today's episode. In today's episode, we are gonna compute the derivative of a sigmoid function. I will show you two ways of how you can do that and why should you know how to compute the derivative of a sigmoid function. Well, the sigmoid function is one of the most common activation functions which you come across in machine learning and deep learning. So it's worth to at least once have computed the derivative yourself, because for example when you apply gradient descent of your objective function, so you have to do the derivative of the objective function with respect to weights, and when you have the sigmoid as an activation function you will have to compute the derivative of the sigmoid function. And to be honest, once you know the derivative of a sigmoid function you will just apply it, you will not compute it again, but it's useful to at least have computed it once yourself in order to understand where this relation comes from. So let's start right away. What's the first way of computing the derivative? Well, we can just start with our definition of a sigmoid function, which is 1 over 1 plus e to the power of minus t. So when we compute, and you can name it x, I just named it t, do it as you like. So we want to compute this one, and what we have to do, we have to apply the chain rule, right? So what we have here, we can rewrite that as 1 plus e to the power of minus t minus 1, right? And this is, so when we apply the chain rule, what we got is 1 plus e to minus t to the power of minus 2, right? Because we have to increment the exponent, and we got times minus 1, because we have here minus. And then we have to take the derivative of that one, and this is just minus 1 e to the power of minus t. So the ones cancel out. And so what we got is e to the power of minus t, 1 plus e minus power of minus t squared. So we can write that out as e to the power of minus t, 1 plus e to the power of minus t, 1 plus e to the power of minus t, because that's just a squared expression, right? And then we can write it as 1 to the 1 over minus t times e minus t, 1 plus the same expression, right? And we see this is the definition of a sigmoid function, right? Over here is the definition. And what we have is sigmoid t times e to the power now minus t, 1 plus e to the power of minus t. And now we apply a trick, we add 0. We can do this because it doesn't change the equation, because we are just adding 0, right? Plus 1 minus 1. Then we can split it up. We can write it 1 plus e to the power of minus t, so we take this part and move it over, and we split this with a minus 1 here. And what we can see is this cancels out, right? So we get 1. And we can see this is the definition of a sigmoid. So the derivative of a sigmoid function is equal to the sigmoid function itself times 1 minus the sigmoid function itself. Very beautiful, elegant result, but a little bit tricky to compute because you have to know this trick over there to add a 1 and subtract a 1. So let's show you the second way on how to compute the derivative, which is a little bit easier in my opinion, but you have to rewrite the definition of a sigmoid function a little bit. So the definition was 1 over 1 plus e to the power of minus t, and we can draw out this e to the power of minus t. Then we have e to the power of t, because that's 1, plus 1. Right? Because we have to round it out, 1. So we can pull e to the power of minus t from the denominator up to the numerator. So what we have is e to the power of t, 1 plus e to the power of t. We are just switching the order in the denominator. So, and this is the second alternative definition of a sigmoid function. And when we compute the derivative of that, it's a little bit easier than in the first one. So let's do that. So what's the derivative of that expression? So we have to apply, let's rewrite it a little bit. And now we have to apply the product rule and the chain rule, right? So let's start with a new line because it will be a little bit longer. So we got, let's do the derivative of that. This is e to the power of t. And 1 plus e to the power of t minus 1, nothing changes here. Plus e to the power of t. And now we have to take the derivative of that one. And that one we already know how to compute, just apply the chain rule. 1 plus e to the power of t minus 2, we get a minus 1 from the exponent. And we got the derivative of that one, which is e to the power of t. What do we have here? We have e to the power of t, 1 plus e to the power of t. This is the definition of a sigmoid. Plus, or minus, because we have here minus e to the power of t, 1 plus e to the power of t, e to the power of t, 1 plus e to the power of t. We can write it as that. And now, what we can see is that we have here again the definition of a sigmoid. So let's draw that out. And we got 1 minus e to the power of t, 1 plus e to the power of t. And this is again a sigmoid. So we could, or we could just skip this line and just directly say, okay, this is also the sigmoid, right? So we have here sigmoid squared. And when we draw it out, we get 1 minus sigmoid t. And we get the exact same result. But in my opinion, the second way is a little bit easier. So if you like this video, comment right down below, give it a like, and if you have some other recommendations of what derivative or computations we can do which are relevant for machine learning and deep learning, then just go on and write it down below in the comments. So, see you in the next video.